Hi everyone, myself Sri Devi, Professor. In this video lecture, we are going to learn about performance measures in image processing. First, we have to know what is image processing and its medical applications. Yeah, it is widely used in many fields such as medical diagnosis, surveillance, remote sensing, and industrial inspection. In medical imaging, especially image processing algorithms are used to detect diseases such as diabetic retinopathy and cancer tumors and stroke, etc. After developing an image processing or machine level learning, it is very important to evaluate how well the model performs. The performance evaluation helps to determine whether the algorithm is reliable and accurate. It is also helps researchers to compare different algorithms and select the best one of the practical use. In image classification and detection problems, various performance measures are used to assess the effectiveness of the system. Among them, the most commonly used evaluation metrics are confusion metrics, receiver operating characteristics curve, area under curve, confusion metrics. So the definition of the confusion matrix is it is used to evaluate the performance of classical classification model. It shows how many predictions made by the model are correct and how many are incorrect. In image classification problems, the confusion matrix compares the predicted labels with the actual labels. It helps to identify how well the classification distinguishes between different classes. For the binary classification problem, the confusion matrix consists of main concepts such as true positive, true negative, false positive, or false negative. These values represent different prediction outcomes of the classifier. True positive. What is true positive? It means or it refers the classes in cases where the model correctly predicts the positive classes. In medical image processing, this means that model correctly identifies the presence of a disease. Example, if a retinal image contains diabetic retinopathy and the model correctly detects the counted as the true positive. True negative. True negative refers the cases where the model correctly predicts the negative class. Example, if the retinal image does not contain the disease and the model correctly predicts as normal. False negative. False negative occurs when the model incorrectly predicts the negative class when the actual class is positive. Example, if the diseased retinal image is classified as normal, it is called as false negative. False negatives are very dangerous in medical applications because they may lead to missed diagnosis and delayed treatment. Accuracy. Accuracy means the overall correctness of the classification model. It represents to the proportion of the correct predictions made by the model. Applications are the performance measures such as confusion metrics, ROC, region of convergence, and AUC are used in many processing applications. Some important applications include medical image diagnosis, cancer detection, retinal disease detection, brain tumor classification, face recognition systems, and autonomous driving object detection, etc. Biometric identification systems also it is used. Recall sensitivity. Recall measures the proportion of actual positive cases and that are correctly identified by the model. Recall is equal to TP divided by TP plus Fn. So here recall is also called as sensitivity. So in medical image processing, high recall is very important because it ensures the most disease cases. So mainly the retinal disease detection, it is used in
மேம்
சார்
போகல
போக வேண்டியதான்.
நீங்கள் முடிச்சுட்டு எங்கே மார்க்கேன்னு தாங்க
ஆ
அதுக்கு ஒரு ப்ளஸ்